Singleton is a pattern that will let you restrict the creation of a class to only one instance, so whenever you create an object of that class, it will always point to the same instance. Imagine you are creating an application that will access the database every time you receive a call from the endpoint to get some blog post, for example. Then you have a class that will connect the client to the database. Whenever you use that class on your application and someone hits the endpoint, it's going to create a new connection to the database. This approach may end up leading to a range of problems, such as resource overuse, which can happen here because a new connection to the database is created every time a request is made, so it leads to an unnecessary amount of resource usage. This can cause the application to become slow and unresponsive, or to use up too much memory and potentially cause the application to crash. It can lead also to inconsistent state if you create multiple instances of that class. Each instance may have a different state because they may try to access a record in the database at the same time doing different operations, for example. And also it can lead to concurrency issues, so which, as I said, is when they try to access the database at the same time. In general, that's when you need to use the singleton pattern. You will ensure that only one instance of that class is created and provide only one access to that instance. To create a singleton class that represents the database client, create database singleton client class. You need also to create a private static instance property and a static get instance method. Now you can check if the instance exists. If not, then you create it and return it. And now you can create methods like query and etc. that will represent how you're going to interact with your client. In the application, you can now inject the database client and query without ever creating new classes like crazy. The pros for this pattern is that you can be sure that a class has only one single instance. Because of that, you will not have the problems I listed earlier, like overuse of resources, inconsistent state, or concurrency problems. Also, if you have only one point of access to the instance, less likely will be that we are going to create a new instance for that class accidentally. And because of the way the class is created, you will need not to worry about initializing it. The initialization will be also happening only when requested. The cons for this pattern is that you will depend on other classes to create a singleton class. If you are, like in this case, creating a singleton that will access a database, you will more likely depend on a lib or class that will provide the bindings to access it. And because of that, the singleton pattern breaks the dependency inversion principle from Solid, which says high-level modules should not depend on low-level modules. Both should depend on abstractions. That meaning that the consumers should not depend directly on concrete classes to get an instance. Instead, they should rely on interfaces. Also, it's usually harder to test singletons because it depends on other resources. From the same example, you will need to mock the access to the database because you don't want it to be accessed whenever you run your tests. The related patterns for this pattern is the facade pattern, which is another design pattern I'm planning to cover here. It can also be transformed into singletons. The flyweight pattern is also a pattern that it's similar to the singleton pattern. Both of them aim to reduce resource usage and improve performance by using objects rather than creating new ones. And that's it for the singleton pattern. If you liked this video, don't forget to hit the like, subscribe. Thank you folks, see you in the next one. Bye.